Alright, so the last problem you have here. Now, this is going to build on what you were doing with all the problems with Mrs. Bauer, but this one actually is going to be a little bit different. We're going to add a little bit more to this one. So we're going to start out the same way, start through the same process, and we're going to realize as we try to solve that something's going to be a little different. So let's just start. A spherical balloon, so we already know what kind of shape we're dealing with, is expanding at a rate of 60 pi cubic inches per second. So we know that's going to be important. If we think of that, if it's expanding at a rate of 60 pi cubic inches per second, what kind of rate is that?
That is a change in volume, so
Yeah.
we represent that as dV over dt.
Exactly, so I'm going to write this up here since I have room, but dV over dt, so that's a change in volume. How fast is the surface area of the balloon expanding when the radius of the balloon is 4 inches? So how fast is the surface area of the balloon expanding when the radius is 4 inches? So how can we represent the surface area part? Daniel?
SA equals 4 pi r squared.
So yeah, we're gonna
represent the
yeah,
change.
yes. How are we gonna represent?
You could do dSA or ds over dt.
All right, I'm gonna use for area. Well, let's just use dA. You can use ds if you want to. I'm gonna use dA. So the surface area and a change rate of time. And what was that you told us, Dan? Before we move on, I'll write that down.
The surface area is 4 pi r squared.
Okay, so we are gonna need area is 4 pi r squared. Now, before we go too far into that, there's one more thing in our problem that we haven't addressed yet. I underlined it, but what actually is that? What did she always represent this at? She used, point in time, P-I-T. And that's when the radius is 4 inches. So at this specific point in time, when the radius is 4 inches, we want to know how fast the surface area of the balloon is expanding. So we have the surface area here. Daniel gave that to us. So what's the first step we always do when we have the formula that we need to use? What do we need to do with that formula? Before we plug anything into it?
Well, you need to find its derivative.
Yeah. So dA over dt equals, how are we going to take the derivative of 4 pi r squared? What's considered a constant or constants?
The 4 and the pi, so you can just move the 2 down to get 8 pi r and then dr over dt.
Exactly. Bring down the 2. The 4 pi is constant, so 8 pi r dr over dt. We want to know how the radius is changing. Or we want to know how the area is changing, sorry. But we need to know how much the radius is changing. Do we know how much the radius is changing? No, we don't know that. Do we know what the radius is at that point in time? Yeah, so we do know what r is. We're trying to find how the surface area is changing, but we don't know how the radius is changing. So now we're sort of in a problem here. How do you think we can go about finding the radius?
We have to use the equation that involves volume.
Exactly. So do you know what that is? I think it's on the front of your sheet. Does anybody have that?
4/3 pi r cubed.
Yep, so we need volume equals 4/3 pi r cubed. Because now we're dealing with volume and a radius here. Do we know the rate of a volume?
Yes.
Yeah, we were given that all the way over here. So what's the first step we need to do with this, though? Same step we did with the other equation. Derivative. What is the derivative of 4/3 pi r cubed? Yeah.
4 pi r squared dr over dt.
4 pi r squared dr over dt. Now, do we know what dv over dt is? Okay, do we know what the r is? And we're trying to find the dr over dt. So, now we can plug in 60 pi, 4 pi, okay, the radius that we're plugging in is 4, so that's 4 squared. and we're trying to find the dr over dt. So we can actually divide all of these over to the other side, and I'm going to skip the steps here for room's sake, but if you divide all of those over, what do you get as your final answer, the fraction, for dr over dt?
15 or 16.
Yeah, if you divide it, maybe you get a fraction, but then convert it to, or you get a decimal, convert it to a fraction, you get 15 over 16. So that's important. We need that now. That tells us dr over dt. That's how much the radius is changing with respect to time. Now, do we have all the information we need to finish this problem over here? Yeah, so this is actually going over to that problem now. So if you want to draw an arrow, just so when you look back in your notes, this we're actually using in that side. So we're trying to find the area, the change in the rate of area, 8 pi. This is 4 for your radius. And now we know the dr over dt is 15 over 16. You can leave the pi in your answer or multiply it into it. Either is correct, but what do you get as an answer? Who left the pi in the answer? Did you leave pi in the answer? Okay, what'd you get?
35.
Okay. And if you multiply pi in, what do you get as an answer? Because some people may have done that. Anybody get the answer with over here?
94.248.
94.248. Now we have to figure out, this is a rate, and we know we're dealing with something over time, so we need to figure out what our units are. So try to look back in the problem. What are our units for this problem?
Inches.
Okay, we know we're using inches, but this is area. So if we have inches, how do we have to deal with inches in area? Yeah, inches squared. Inches squared over, what is our time? Seconds, yes. Inches squared over seconds. So 30 pi inches squared over seconds. And that is your final answer. Any questions about that problem? Pretty straightforward. Getting a little easier. I mean, I know at the beginning, Mrs. Bauer said, the more you go through these, the easier they're going to get. You've gone through quite a few examples now, so they should be starting to get a little easier, figuring out the process and what you're actually trying to find. All right, if there are no more questions, I'll leave this up here for a few seconds, but the rest of the time is for you to get a jump on your homework, and then tomorrow just be ready for the free response day, okay?
Let's check our email. Let's check our email.